Hey guys, welcome back. This is Tim's Electronics Lab. I'm Tim, and in this video I'm going to show you how to make a wireless and battery powered ESP8266 for outdoor usage. So let's get started. So to get started you need a few things. One of them is of course a ESP8266, a prototyping board, solder of course. I'm going to use an 18650 lithium-ion cell, a couple of wires, the TP4056, this is your charge controller, some headers, and I prefer a connector to connect the USB charge controller to the ESP. So let's get started then. So in order to make the ESP8266 battery powered, you'll need a couple of things. I'm going to use a Samsung 18666. I'm going to use a Samsung 18650 cell. This is a lithium battery cell. Of course, a ESP8266. A TP4065 battery charge controller. You could use some headers in order to connect the battery to the circuit. I will be using that. Some wires, solder of course, headers, and a prototyping board. So and of course your standard tools, and also a soldering iron is really useful. So the first thing you'd want to do is to get the battery charge controller and to prepare it without the battery connected, since there will be some power in the battery. You might need to check the voltage, but yeah, connecting the battery is the last thing you'd want to do. So we're going to prepare this board first. Now, let me grab my tweezers. On this board you've got a couple of solar pads. These two over here. Let me zoom. These two solder pads are for the power input. So you can connect a solar panel to them, for example, or another battery if you don't have a micro USB connector. And if you flip the board around, you can see that there is out plus and out minus written on the board, and B plus and B minus. Now of course the B is for the battery and the out is for the output. So I'm going to use this wire for the positive terminals and the black wire for the negative terminals. So let me cut them in half. Let me split them like that. So now I have two, and I need two black wires as well. Like that. Alright, cool. Now each wire needs to be separated, so I need to separate the black wires as well, which is a little tedious, but a wire cutter is a good helping hand over here. So there you go. Alright, now let me zoom out and turn on my lamp, because it's going to get a bit dark. You need solder. Now this is a lead-free solder. I bought it by accident. I didn't know it was lead-free. So we will see how it works out. And I'm going to use a helping hand in order to solder everything to the board. And I will start with the input connections. Like that. and you are able to see it. So pre-tin your wires, that's always really good to do so. So that's one, and yeah, just put the wire in the terminal, hope it will hold, and just solder it in place actually. Alright, I must say this lead-free solder is really good. I ordered a lead-free solder from Banggood and I wasn't satisfied with that at all. The melting point was off all the time, it didn't flow properly, but this is really good. It's from my local hardware store, so shout out to them. And solder the negative lead like that. Now there are wires sticking out, and I will trim that in a moment. Actually flip the board around. Like that. Oh, I need another gray wire, I think. Yes, I do. Oh! Here you go. So, another gray wire. Now this one is a little too long, so I'm going to cut it. Use my wire stripper. So this one is a little too long, so I'm going to use my wire stripper in order to strip the wire. And let's solder that one. Alright, this is for the output. So that to the output. Oh, the solder block on the end is too big. There you go. That one won't stick in. So, alright. Solder it in place. Now the other output wire. Let me grab one. Black wire. Now this one is also too long, so I'm going to cut it and again strip them with my and again strip them with my wire cutter. So pre-tin them. Like that, and stick it in there. Hope it will stay in, which it will, which it stays, and solder it. Alright, nice. So now comes the interesting part, actually. Well, interesting. Now we're going to solder the battery connections. And it's just normal solder, so nothing special to do. Just solder the wires and don't connect the battery yet, since yeah, otherwise the battery is connected and you can't solder the rest of the hardware in place without the possibility of shorting your battery, and that is the last thing you want to do. So with this one, use a little bit more solder, like that. Nice. So now we've got a fully connected battery charge controller. We can remove it from our helping hand and look at the result. So now we have two wires. These two wires are the input wires. the outer two wires of the other side are the output wires, and the inner two wires on the other side are the battery connection wires. So now we are going to solder our ESP8266 on the breadboard, on our prototyping board, sorry. For that we'll be using headers, so put on the headers and cut them to length about here, I guess. Yeah, make sure you include all of the pins, so you can't have a single pin missing, so keep an eye on that whilst cutting the header. So now the header is cut, and just stick it in the prototyping board and solder the header onto the board. It's as simple as that. So like that, we've soldered all the, well, not all, we've soldered all the corners of the headers. Ooh. Flip the board around. Ah, shit, that's hot. So like that. Now all the header pins have been connected. So now I'm going to put on the terminal connection block. I'm going to do it in the middle, beneath the chip, so you can't accidentally unscrew it or something. If it is able to go in like that, so solder that one. Now I always like to pick a side for a single side for each of my positive and each of my negative connections, and that is this side. The left side is ground. Yeah, the left side is ground, and the other side is no, that's wrong. The left side, yeah, the left side. So you'll be using the left terminal as your plus voltage and the right terminal as your ground voltage, because it matches the V in and the ground pins you need to use on the board. You need to make sure that you are using the V in pin. The 18650 cell will have a maximum voltage of about 4.2, and the ESP8266 accepts a maximum 3.3 rail voltage of 3.6. So if your battery is fully charged and you connect it to an ESP8266, you will blow the shit out of it. So that's not what we are going to do. Now we need to connect the right terminal to the first header pin. So I'm going to just make a solder bridge to connect them. This is a little bit difficult with unleaded solder and a tiny solder string diameter thingy. But I will manage. Like that. And be careful, because the ground connection on the ESP8266 is not the first one on this side, it's the second one. So you actually need to make a solder bridge to the second pin. So that's this pin. Like that. Like that. So now we've connected the block terminal. Now what we're going to do is connect the battery charge controller outputs to the input of the terminal. Now I'm going to flip the cable on itself and solder it so we have a good connection. And I'm going to do the same with the ground output lead, but I need to strip it first. Oh, that's a little bit too long, but hey, now we've got a good connection point to make like that. So nice. Alright, so watch your ESP and connect the negative wire to this terminal like that. Connect your positive wire to the other terminal. Make sure to unscrew it first, otherwise it won't go in. Pro tip, screw it in place. Alright, now we are ready to solder the battery. I don't have a fancy, how do you call that? You know, spark soldering tool, welding tool, battery welding tool. But solder will manage. Now you need to do it quick because heat is not very good for the cells. So make sure you've got plenty of solder on your soldering iron. Now I'm going to use a little bit thicker solder. Yeah, it's leaded solder with a lower melting point, and just add solder to the battery terminal like that. Now it won't stick there. There you go, that's hot. And now on the other side, of course the battery will fall because it's unstable. And solder. There you go. Alright, so pre-tin the proper wires like that. Get your battery and make sure to connect them to the right side. So this is your positive side and this is your negative side. So the black wire of course needs to go onto the negative side. So just solder them in place like that and give it a strong pull to make sure it's soldered correctly, and solder the positive side as well. and give that a strong pull to make sure it's soldered correctly. And oh, we need to do something first. Clip off the leads of the wires. You need to do that first before actually connecting the battery. So to verify that everything is working, grab your multimeter and measure the voltage on the prototyping board all the way around, so like this. Now I see that my battery has 4 volts. Now that's not true, that's the output of the battery management controller, the battery charge controller, I may call it. It tries to boost it to 5 volt, I think, because if we take a look at the battery voltage, it's, oh no, the output of the if we take a look at the prototyping board, you'll see that the output is 4.08 volts, 09 actually, almost, and that is the output of the battery. So this voltage is on the battery, and this is the reason why you want to connect the output of the battery to the V-in terminal and not the V3 rail, because this will blow up your ESP. So that's alright. Now take back the leads, and if you plug in your ESP, the light should come on actually. There you go. I'm going to unplug it and plug it back in. Like that. So it's working, nothing gets hot, and the charging is working. And I'm not sure why it went out. Oh, maybe because it's, oh, I think that's got a connecting sketch on it. Yeah, I think that's a connecting sketch. So if we take the lab bench power supply and we put it on and connect it to the input leads of the charge controller, like that, and turn on the output of the power supply, we can see now, I can see that the battery is charging at a current of about 700 milliamps on 4.77 volts. Now the power of this charge controller is that the input voltage does not need to be stable. It can handle input voltages up to 10 volts. So now the input voltage is at 7 volts, around 7 volts. I'm going to put it up, and the funny thing is that the current starts to drop when you increase the voltage. Now the thing is not doing anything. I think it's charged, but I'm not sure. Ah, shit. No, that's gone into thermal protection. Yeah, that's gone into thermal protection. The chip is way too hot, so that's another thing to keep in mind. So sticking the wire from the bottom. Ooh, almost burned my finger. And with that, closing the solder cap. Oh shit. There you go. Got some solder. Like that. And to do the same for the other one. Like that. Now the output connection goes like that. And the other connection goes like that. Alright, cool. Now the internals. Right, some room. Someone. No, shit. That's not how I meant it to be. Alright, cool, one left. Alright, cool. So, there you are again. Now, again, connect the output to the output inputs of the chip. Like that. And like that. And grab your, oh, that's the wrong one. Oh, come on. Just go in there. Will you? Yeah, like that. And screw it in place. Oh, it slipped out. Come on. Screw it. Now it didn't slip out. Alright, so that's connected. Now once again grab your battery and make sure to connect the grounding wire first. And then the positive wire, and solder that in place. Now once they're connected, again grab your ESP8266, put it in, and you'll see that the light came on. Now the old one is in the bin, so that's good. Now if you are using this with a solar panel, it will charge and allow you to use it at the same time, so that's no problem. The only thing is that the charging, of course, will take a little longer. So you can see that we have a fully functional battery powered ESP8266. I'm using it in one of my projects. This is part 1 of a video. For part 2 I need to buy some things in order to make it waterproof and print a nice little box for it, so we can put it outside. I might need to order a solar panel as well, so keep an eye on that one. Thanks for watching this video. I hope you've enjoyed it. If you did, please leave a like. Make sure to leave a comment down below. You can also share this video with your friends if you think they will like it too. See you next time.